This video is to show how to rotate a shape using tracing paper, or how to describe a rotation that's already been performed. So we've got this triangle drawn here, and we've got two questions. It tells us first of all to rotate it 90 degrees about x. So it's telling us three things there. It's telling us first of all what type of transformation we want to rotate it or turn it. This tells us the angle, and this tells us where the centre is. So if we're going to rotate it using tracing paper, first of all you need to make sure the tracing paper is big enough to cover the shape and also cover the centre of rotation. So what we need to do is first of all trace the shape. So I'm going to draw on the put on the vertices of the shape, and now I can join those up with a ruler. Right, so we've got our triangle. Now we're going to rotate it, we're going to turn it, and the transformed position is where it ends up after being turned the 90 degrees. Now, important thing to note is that when it says 90 degrees, you might think, well, it doesn't tell us which direction to turn it. We could turn clockwise, we could turn anti-clockwise, it doesn't say. But the positivity or negativity of the value tells us. When it's plus 90 degrees, which this is, that means anti-clockwise. Or if it's in minus 90, which the next one is, that will be clockwise. So to rotate it 90 degrees about x, there's our point x, that's our centre of rotation. That's the point that doesn't turn, that stays in the same position while everything else turns round it. So notice that I've got the tracing paper, I've got a pretty much square on to the grid. So that helps me know when I've turned it 90 degrees. I can tell when a rectangle or a square has turned 90 degrees. So we'll turn it through 90 degrees, anti-clockwise. Okay, so now that's about 90. So what I'll do now is I'll just lift up the tracing paper one corner at a time and mark the positions of the vertices now. So one goes there, there's the other one just below the centre rotation, and then the last one's just there. You notice with a rotated shape that it's the same size, the sides are the same length, the angles are the same, it's just changed position, it's rotated round. The second question asks us to rotate it minus 90, so we can start again in the same position. It's the same centre of rotation, but this time the question asks us to turn it minus 90, so that means clockwise. So again, the tracing paper is about square one, so we want to turn it until the square is rotated through a quarter turn. So there we are. So let's put this position in first on the right. This one here just below the O. And then just above the X. So there we are, rotated 90 degrees anti-clockwise, rotated 90 degrees clockwise. Let's have a look at another example. This time we've got it on a grid. So we've got two axes drawn, and we've got the centre of rotation here marked with an X again at the position 1, 1. So again, we're using tracing paper. I'll trace over our shape. and this time it's this point here that's staying still. So this is where we put a pen or a pin or whatever, something sharp to keep it in place. And we're going to rotate it this time 180 degrees. Now 180 degrees, if you go clockwise or go 180 degrees anti-clockwise, you end up in the same position. So it's usually just written as 180. So 180, there's 1/4, there's another quarter, half a turn. So goes there, goes there. Now I know the shape's not going to change size, the angles don't change, so what I can do now, rather than using the tracing paper, I can say, right, that position there is rotated round to there, and you can see that whole side is rotated round to there. And so that means the head of the flag, that's rotated round and will now be facing that way. But this will, here is point A, and here's our new point A dash. D's rotated round to here. And what I can do is I can say, right, that bit's 4 long, then from the middle we go out 2. So 4 long, go out 2. So the new flag will look like this. So the point B has been rotated round to there. There's our point C dash. We've rotated 180 degrees about our centre. Last one, here we're asked to describe a transformation. The shape has already been transformed. We can see it's been rotated. It's the same shape, but it's just turned. It's not changed size, it's not been flipped over or anything. So we know straight away that this transformation is a rotation. Now we usually use the word object to talk about the shape that's drawn first, and then the transformation of it is the image. So this is the object, this is the image. How do we know? It's because the convention is that for the object the letters are written like this, and for the image they have the dash. So we can see that it's being transformed, it's been rotated around like that. Let's check with our tracing paper, just so we can see. Now what I'm going to need to do is I don't know at the moment where the centre of rotation is, so I want to be able to include the shape and the centre of rotation on the tracing paper, so I don't want it too near the edge. So the shape's gone from there and it's rotated around to there. Now which way is that, clockwise or anti-clockwise? Starting here and going that way, it's anti-clockwise, isn't it? And it's a quarter of a turn, so 90 degrees. So remember, 90 degrees anti-clockwise, that's positive 90. So we can put it like that. But now we just need to state what is the centre of rotation. And to work that out, one way to do this, and maybe the easiest way to do it, is just by trial and error. Now usually the coordinates of the centre of rotation will be with integer numbers, so 0, 0 or 1, 1 or 2, 2 or something like that. So what we need to do is just try different values until we find the centre that works. So a good place to start is 0, 0. So if I rotate it now 90 degrees anti-clockwise,